So hey guys, so today we're going to take a look at a linked list problem. So the problem statement defines that we're supposed to find if there's any cycle within a provided linked list. So for example here, like we've been provided with the linked list and you have all these nodes, right? And if it did end up traversing the nodes, so we go to 3 first. Head 3 would basically be the head, and we go to 2 and then 0 and then -4. And then minus fours next would be two again. So it you would then go into a cycle where two would call zero, and then minus four would again call two. So that's kind of the idea of like having cycles in a singly linked list. So the way that you would solve it is by making use of two pointers. So you would have two pointers for a linked list, and one of the pointers will be a slow pointer, but the other pointer would be a fast pointer. And the slow pointer, we would be iterating it just once for every iteration, but the fast pointer, we would be iterating, we would be iterating twice, right? So for example here, like initially when we started the problem, if we had like the slow and the fast pointer right at 3 here, and then during the next iteration, the slow pointer would just move to the next node, but the fast pointer would skip 2 and then go to 0, right? So you're skipping a node and then going all the way to 0. And then during the next iteration, the slow node would come to 0, but the fast node would go all the way back to 2. And so we would do the same thing, and we would iterate till either one of those slow or fast pointer reaches null, or if we find that both the slow and the fast pointer are pointing to the same node, then we would stop the iteration and return true. But if we don't reach the same node, but we still get to the end of a linked list, we would just return false, meaning that there's no cycle with the provided linked list, right? So that's kind of the way to solve this problem. It's fairly straightforward. So I'm going to solve this. I'm going to write out the Java code to actually solve this issue. So a few base conditions first. I'm just going to check if head is equal to null, meaning that we don't even have a linked list. So in this case, you can just return. If you don't even have a linked list, you don't even have a cycle, right? You can just return false. And then you can declare two pointers, which is the fast and the slow pointer. So I'm going to do that. I'm going to declare a pointer called supposed to be list node, and then slow, both would be pointing to head initially, so I'm going to do that. And then fast equal to head, and then you're going to start the iteration, right? So this is where the tricky part is. You just have to check for a few conditions right when you do the iterations. So I'm going to check for a few conditions. This might be long, but it's actually better to do it. You want to check if slow is not equal to null, and you want to check if slow dot next is not equal to null, and then you also need to check if fast dot fast is not equal to null. You also want to check if fast dot next is not equal to null, and I'll tell you why that we need to check it. There's a reason why we do this. And then first dot next is not equal to null, right? There's a lot of conditions, but it'll be worth it, guys. So uh, right when we start the iteration, kind it's always better to like, so, okay, so we have the slow pointer and we have the fast pointer, right? So those are kind of the two pointers. So every time we iterate, we want to move the slow pointer to the next node, right? So we're just gonna do next. But with the fast pointer, you want to be able to skip a node and then move one step ahead the slow pointer. So in that case, you can just do next dot next. So this is why we're checking for a null condition here, because we don't want to have the first dot next as null. So once we do that, you can just go ahead and check for the condition, which is if slow is equal to fast, and if they're equal, at this point you can just return true, meaning that we did find a cycle within the graph. But if we did not find a cycle within the graph and we reach the end of the linked list, then that would mean that the linked list has no cycle at all. So you can just return false here. So that's pretty much it. Let's run and see if it solves the problem. So this is also, I'm going to submit now. Yep. So That is pretty much one of the easiest problem from linked list, but it's always good to know. So thanks for listening, guys. See you again tomorrow with another problem.